go ahead and write down your name. And right here, go ahead and write down our objective, which says students will be able to perform operations in scientific notation. Remember that you can pause this video anytime if I'm going too fast, but make sure that your name and our objective for today is written down right here. Today we're going to be working on how to perform operations, addition, subtraction, multiplication, division, in scientific notation. We're going to do 4 examples. Here's example 1. The mass of the Earth is 5.9 times 10 to the 24th. The mass of Pluto is 13 with 3, 6, 9, 12, 15, 18, 21 zeros behind it. Since this is such a large number, I'm going to convert that to scientific notation so that it can actually be used and be more readable. In scientific notation, I want my decimal to be right here, so I have only 1 digit in front of that decimal point. But I had to move the decimal 3, 6, 9, 12, 15, 18, 21, 22. So it's 1.3 times 10 to the 22. And the question asks us, compared to Pluto, how many times greater is Earth's mass than Pluto's mass? Let's see, Pluto's mass is here, 1.3 times 10 to the 22. How many times greater than Pluto's mass is Earth's mass? So I want to go, how many times greater is Earth's mass, which is 5.9 times 10 to the 24th. Now, let's start with our exponents. 10 to the 22nd times 10 to the what would equal 10 to the 24th. Well, I know if we're multiplying these exponents, I would add those exponents up at the top. So 22 plus 2 would equal that 24. But now I need to see 1.3 times what would equal 5.9. I don't really know that off the top of my head, but I could use a calculator to figure it out. 1.3 times what equals 5.9? I could just do 5.9 divided by 1.3 on a calculator, and that gets us about 4.5. So we can look at this as 4.5 times 10 squared. Earth's mass is 4.5 times 10 to the power of 2 times bigger than Pluto's mass. And there's an example of multiplication with scientific notation. Let's go down to example 2. Determine the combined mass of the Moon, Earth, and Pluto. It says combined. That means we're going to be adding all of these together. The mass of the Moon is about 7.3 times 10 to the 22nd kilograms. The mass of the Earth is 5.9 times 10 to the 24th kilograms. And the mass of Pluto, we know this from the last one, is 1.3 times 10 to the 22nd kilograms. That's what we did in example 1. We want to add all of these together. But here's the thing, when we're adding exponents together, I want all of these exponents to be the same. We've got a 22, we've got another 22, but this one we have a 24. I want this to also be a 22 because it's going to make this way easier for us to add together. So I want it to be 10 to the 22nd power. I took 2 away from this exponent, so I know I'm going to need to move this decimal point 2 places. If I made this exponent smaller, I'm going to need to make this number bigger so that they're still equal to each other. So I'm going to move it 1, 2. It's going to be 590 times 10 to the 22nd. I could multiply this out to check that it's still equal to that, but for now I think I'm sure of my work. All right, let's add these together. We've got 7.3 times 10 to the 22nd. We've got 590, I'll add a 0.0, times 10 to the 22nd. And we have 1.3 times 10 to the 22nd. Add these all up. Adding all these 10 to the 22nds together is still 10 to the 22nd, because this is like having 22 zeros plus 22 zeros plus 22 more zeros. It's just going to be 0, 0, 0, 0, 0, 0, 0, 22 times. Then we'll add this part up right here. 6, 8, 9, 5. So we get 598.6 times 10 to the 22nd. Now that I have an answer, though, I need to put it in correct scientific notation. So I want my decimal point to be right here. Move it 2 times this way. 5.986 times. See, I made this 2 times smaller. I'm going to need to make this 2 bigger. Times 10 to the 24th. And that is the combined mass of the Moon, Earth, and Pluto. Alright, we've got 2 examples left. The Sun produces 3.8 times 10 to the 27th joules of energy per second. How much energy is produced in a year? If a year is approximately 31 million seconds. Let's go ahead and write this in scientific notation so we can work with it. 3.1 times 10 to the 7th, because I'm going to do 3, 6, 7 times. Now here, we're thinking about joules of energy per second for this many seconds. So I'm going to multiply these 2 together to figure out how many joules of energy the Sun produces in 1 year. So I'm going to do this times the number of seconds that we've got. First, I'm going to multiply my exponents here. 10 to the 27th times 10 to the 7th. I'm going to add my exponents up here. That would equal 10 to the 34th. Then I'm going to multiply these 2 numbers I have here, 3.8 times 3.1. I don't know that off the top of my head. I would use my calculator. On my calculator, I get 11.78. But again, I want to put this in correct scientific notation, so I'm going to need to move the decimal right here. 1.178 times, see I made this 10 times smaller, got to make this 10 times bigger, 10 to the 35th. So our Sun produces 1.178 times 10 to the 35th power. That is a huge number. All right, now it's time for our very last example. Mercury is about 57 million kilometers from the Sun. Neptune is about 4.5 times 10 to the 9th kilometers from the Sun. What is the difference between Mercury's and Neptune's distances from the Sun? When it says difference, I know I'm going to be doing subtraction here. Subtraction is really similar to addition, meaning I want my exponents to have the same power. This one is 10 to the 9th, so I want to make this one be 10 to the 9th as well. So that means I'm going to need to move my decimal 9 places to the left. So there's 3, 6, 7, 8, 9. So I need to add a 0 in front of here. That's 0.057 times 10 to the 9th. Now we're doing the difference here. So that means we're going to be subtracting. And do 4.5 times 10 to the 9th minus 0.057 times 10 to the 9th. Again, this is just going to be 9 zeros minus 9 more zeros, which is just going to give us 9 zeros. And when we subtract this, we get 4.443 times 10 to the 9th. Our answer is already in scientific notation. So we know that Neptune is 4.443 times 10 to the 9th farther than Mercury.